Alright guys, so we're at that stage now where we can start to look to add a 3D model. Now I'm going to provide you with a 3D model that comes from Quaternius. It's CC0 so that you can use it in your project if you want. And animations and also instructions on animations and where to get them and what you can do. So you can bring your own if you want, or you can use the stuff I've provided, or you can go and you can follow this video. I've got a model here, and what I'm going to do is I'm just going to export it as an FBX. The one thing I would point out is that you want your model to have its arms and legs sort of in a T-pose position with its thumbs pointing outwards if you want to use Mixamo. It just works better if you do it that way. So we'll export that as FBX. If you have your own model, you can use that. I got mine from Quaternius. He's a really good CC0 creator. I really suggest you check out his Patreon. He posts a lot of stuff there. That's where I got this from, the Modular Men Pack from 2022. And so I've been able to download that and sort of clean it up a bit so that we can use it in this project. It also has its own animations, but we're not going to be using those. Okay, so back in Mixamo. Mixamo is a 3D animation software that allows you to upload a character, which we're going to do now, and sort of add animations to it. So you want to create an account, set it all up, and once you have the option to upload a character, hit that upload character button and just select your FBX, and it should just load up here. If you have any problems, just try to check out the troubleshooting. It can sometimes be a bit tedious if you haven't set things up properly, but I am no expert, so I'm not going to go into details on how to fix that because I wouldn't know. You should end up with your model being visible here. Click next, and now we'll have the option to place these markers in position. It's got a little diagram on the right hand side for us to follow. So chin, obviously where the chin will be, wrists where the wrists will be. Depending on the model, sometimes it can be a bit difficult to exactly determine, but you can see here with the elbows, I can pretty clearly tell where the join should be based on the vertices in the mesh. Sometimes it's not that difficult. I've had problems in the past, I can tell you that much. Same with the knees and with the groin as well. Now I've got symmetry on, it's that way by default, and it's using the standard skeleton, which is obviously has fingers. So we hit next and it should just do its thing. Shouldn't take too long. It says up to 2 minutes, but I've never seen it take that long. And then once it's loaded up, we'll get a preview of our character here and we'll be able to confirm that. It should just look like the above, pretty normal stuff. You click next and it's going to say it's going to replace my old character, but my old character is this one, so it's no problems. So the beauty of Mixamo is it gives you the ability to just choose any character animation here and it will apply it to your model, which is really powerful. So anything that you want, you can put in your game. They're not always the best for game development. This is made with multiple applications in mind. So some of this stuff might be better for CG animation, but definitely we can use some of it for sure. Play around with it, see if you can find something unique. There's a lot of options. So I'm going to grab a pose, just like a T pose, and I'm going to download this, and it will give us an option to download as an FBX with the skin at 30 frames per second. So I'm going to choose with skin. I'm going to download that, and actually what I'm going to do is start a new Blender project. So I'm going to go new, just general, and I'll save this one and I'll leave it behind. And as typical, we'll just delete everything in the scene. We don't need it. And what you can do with FBX files, now this is 4.3, so if you don't have 4.3, you might have to go through like the regular import process. But now with 4.3, you can just drag and drop these FBXs, which is a real lifesaver, especially for the exercise we're about to put ourselves through. So we just drag that in and hit import. So we just hit import and we've got ourselves our model in T-pose fully rigged up for Mixamo animations, which is going to let us just bring in any animation we want. So what we are going to do is actually just save this as a new blend file. So I'm going to give this one a name. I just call it Spacesuit Animated. We'll just save it as separate, just so that you don't end up losing any of your project or if you've got a model. What you might notice is that the scale of the character is 100 and the armature is scaled down to 0.01. And so what you can do is you can press Control A, which is the apply hotkey, And there's an option to scale to deltas, which converts normal object transforms to delta transforms. So this is a really cool function because it's just going to help us fix this scale, which is going to be really important when we take it to the game engine. And so now that's set to us with a 1:1 scale, and I'm also noticing that there's a rotation. So I'm just going to control A and set all transforms to delta rather than just scale to delta, because I want to make sure that it's fully zeroed out. And so I'll do that for both the object and the armature. And so we'll have a very nicely positioned character. I've got a list here because of the way the website works. I can't just directly link you these animations, but I can give you the search term, if that makes sense. So I've narrowed it down to like the description, so they should come up. So I've got a list here that I'm going to go through. I'll grab the first one. You won't be able to see it because it's off screen. I'll just paste that in, fast run. I want to tick in place. So some of these animations, you'll see that the character moves and you'll get the option to make it so that it just runs in place, which is what we want because we're going to be moving the character manually. The other thing to look out for is the arm space. So I've seen it in the past where just because of how the rig is, or the character, that the arm space needs to be like set wider or lower. And so that'll just be something that you can cycle through each frame to just make sure that it's not clipping anywhere and it looks right. And generally speaking, once you're happy with how it needs to look, you can sort of apply some of these settings. Not every animation is going to have the option for arm space, but it's definitely worth checking if there's an option, because I've seen it where the arms just clip into the body and stuff. This one looks pretty good. I don't think we need to change anything. So we're pretty much good to go. We can just hit the download button on this, but instead of downloading with the skin this time, we're going to download without skin because we don't need the model more than once. So now I'm going to go through and download every single animation. I won't put you guys through the process of watching me just search these terms and download them. There's a list in the project if you want to follow along. So just go through and download each one individually and then save them in a folder, because we're going to drag and drop them like you just saw over and over again. So we'll get into that and I'll see you back when I've downloaded all of these. Okay, welcome back. So I have downloaded those animations here. I've got the big folder full of them. Hopefully you've organized them in the same kind of way. So now we can start the process of applying these animations to this model. Now I want to stress that this is something that's not just generally possible. This is because Mixamo and these animations have the same animation data. Because we have Mixamo, we have this fortune of being able to apply these animations very easily. So what we can do is essentially I can drag in this, say this walking animation, and import that like this. Now, all we have to do is we'll go to the animation tab here. What you'll see is a dope sheet. Just make sure you're in object mode as well. I don't know what changed me to pose mode there. You'll see the dope sheet, and you'll also have the action editor if you click this little drop down menu here. And what you'll see is you've got this another drop down menu with the different animations. They're kind of hard to understand what they are, but if you click the armature, and you then select the new animation, what you'll see is that they're suddenly doing the same animation. And then you can just click X to delete selected object, remove the empty armature. And now we've got that animation applied to our character model here. Now, the other thing I suggest you do is change the name to something that's understandable. So I'm going to change this to walking unarmed. So that's literally all we have to do. And you've got this animation. Okay, so I will show you as well how to import from the old-fashioned way, just in case you don't have the ability to drag and drop. So if you click File and click Import and then FBX, navigate to your folder. This is the one I'm doing. So if you grab anything else, like say I want to do sprint forward now, that'll just import like so. You can just delete it and select the character model, and this one is there. We rename this to sprint forward armed, because this one is when he's holding the weapon. And that's literally it. We're just going to go through, import all your animations, rename them, and I'll see you when we're done. Okay, so we're back and now we've got all our animations. You can see this one is pistol pose. I've decided to hand animate the shooting animations, but if you don't want to go through that process and you just want to use Mixamo, that's totally fine. I find that their animations are a little bit too slow for my liking, and sometimes the poses don't exactly match what we've downloaded. But you're welcome to download these. So if you just type in Mixamo, type in gunplay, there's a couple here that could work really well depending on how fast you want the rate of fire. This one looks pretty close to the pose that we're in for our rifle, so it might be a good choice. And you can also trim the animation if you want it to be shorter. And there's one, if you scroll a little bit further down, just called shooting, which is a pistol shooting. I'm fairly certain this is quite different from our pistol idle pose, but you know, it could be good. And then the other thing that you want to look for is the melee animation, because I'm going to hand animate that. The exact one is great sword downward slash. So this perfectly matches the pose of our melee idle. And so it should work pretty well. I think it's a bit too slow for video game, but you know, that's just me. So I'm hand animating. Mine won't look nearly as good, as you can tell from this animation of the sword. And so they're pretty basic, but you know, you just have to bear with me because that's just how I like to do things. It's not super important. If you've got your own animations, you can use those. So now that we've got all of our animations in the editor, so we're happy with how they look, all we need to do now is just come up to the file and export that as an FPX. Now, in the past, I would suggest a GLTF, and GLTF is perfectly fine if you want to use that too. But Godot 4.3 especially, if you're on older versions, definitely use GLTF, but Godot 4.3 has gotten really good at bringing FBXs in. And it's just a little bit easier to work with in terms of what you see in Blender versus what you get in the game engine, in my opinion. So you are fine to export as FBX now, which is great because that's more in line with what other engines are using. And you can just export it to whatever folder you want. I'm exporting this to the actual project area so that you guys can have it, spacesuit animated, and just bring that into your project. It might take a second and we'll switch over to Godot. Finally, we're back into Godot. So I'll just open up Godot here. Open up the project, which is for me third person shoot tutorial because I misspelled the project name. Okay, so now we're back in the project. We actually need to bring that FBX in. You might have already just automatically exported it, but for me, I haven't. So I'm going to right click the file browser and click on open in file manager, which will open up in Windows here. And I'm just going to copy and paste the spacesuit animated FBX file. And I'll create a folder as well, just called character animation, character model, I should say. And I'll just put that FBX in that folder. And Godot should do a little import here. We might get a small error or warning, but most of that's fine. And now just do a quick test and drag that into your project to see how it looks. Mine's looking pretty good. He's facing the wrong way. That's not a big deal. We can flip him around. Sometimes these things will happen. So we can just rotate this guy by 90. By 180 and flip him around so that he's facing the right way. And then everything should be fine. We've got all the animations. They've got armature at the front, but you know, other than that, totally readable. But you might notice they're not looping, and we're going to have to go through another process here in terms of storing these animations for being able to edit them and also re-importing the project and just working with 3D animation in Godot. So this is a pretty important step that I recommend you follow. So if you double click on the FBX file, you end up with this advanced import settings window. And so what we need to do is just for each animation, click save to file. And depending on the animation, so for a lot of them, we do want them to loop. So for the loop mode, we want linear. There's a couple where we don't need that. For example, the shooting, the reloading, maybe equip weapon. For the rest of them, we do want them to be looping. So the loop mode, we want to set to linear. That just helps us if we have to re-import, to be honest. As we just go through this and saving the animations, we might as well set them up as looping because we need them to loop. So we want to save to file, set enabled. We want to set a path for the file. I'm going to go to assets, character model, and I've created a folder called animations, and I'm just going to put them all in there. And then you will have to like write in the name of each one. So I'm just going to copy and paste from Blender, but you can name them whatever you want, but it's probably easier if you name them the same as what they are in Blender, just to make it easier to keep track of what's what. So I'm going to go arm run backwards right for this particular one that I'm looking at, and then just keep custom track. So now we're going to go through, and I'm just going to skip ahead so that you guys don't have to watch me do this for every single animation. At the very end, we want to click re-import, and it'll re-import the model. And then all we need to do is just check that folder and make sure that it's got everything that we've set. So we've got all the animations saved. And then the reason we need to do this, I skipped this before, is that there's a warning you'll see on this animation player that says this animation belongs to an imported scene, so changes to imported tracks will not be saved. And in order to modify this animation, you need to go to advanced import settings, set the loop, and to add custom tracks, enable save to file and keep custom tracks. This is something that we do want to do, so we have to do it. So that is why it's basically this warning that you see. It's never going to go away, so just don't worry too much about it. And that's that. Let's remove this old one from the scene, and next we can add our model in and start working the camera and adding the animation tree. I'll see you there. Alrighty guys, welcome back. We're ready to start creating our character model for this third-person controller. First things first, we've got a mesh here that we no longer need. So we can just go ahead and remove that. I'm going to delete. And what I like to do in this case is actually create a new scene for the character model. So I'm just going to call it character model. And essentially, I'm just going to bring in that spacesuit animated FBX file. I'm going to reset its position so it's in the right spot. And it can just be a child of that, and we can stack all the other different nodes that we need to control this animation, because it will become quite complicated as time goes on, in this node, and have a script to run all that separate from the player, right? And we'll just call signals to the player and everything will work really smoothly and not be interconnected, if that makes sense. So you want to click editable children, not make local. I know I did in the other one, but that was mostly just so I could show you guys the node and all that kind of stuff. Editable children is much better, because if we need to re-import this, we want to make sure that everything still is linked up, essentially, because if we make it local, when we re-import, we'll have to delete the node and bring it back in, and it gets messy. It's not impossible, but it's just better just to make it editable children. We've got all these animations, right? But how do we control all of this, right? How do we know what to do and when, right? We've got these animations and we want to play. Okay, so we want to play the walking forward when perhaps we're aiming. And have we got run forward unarmed? Yep. When we're moving forward, we just want to play this animation, right? And all that kind of stuff, you know? So the way that we can control that, first of all, is with an animation tree player, or animation tree as it's called these days. And this is really important to have because it allows us to blend the animations together. So we need to assign a nim player, and we also need to do a tree root. So the tree root for us, I like to use the blend tree. You can also use state machine, that's perfectly fine, but essentially there's a couple of different ways that you can run these and it works totally fine. So we use a blend tree and we need an nim player. Obviously we're going to assign that to the nim player from the imported animation, right? How can we get animations to play? We simply just right click anywhere on this grid and we can choose between a bunch of different choices, right? Animation being the most basic, right? That allows us to choose any animation for this particular node, right? So let's just say if we want that walk forward, where is it? Walk forward unarmed, gets pretty long, and we just connect up that to the output. And you can see that our animation just starts to run. But we need something more complicated than this, right? We need to be able to choose between a bunch of different animations. So we have something here called a transition node, right? And we can actually put this in between the two and transition between the different states, much like our state machine. And so what we can have here is inputs, right? And we can add elements and add elements and add element. So we might have idle, we might have walk, we might have run, we'll just call it run, sprint, and we also have jump, right? Okay, and say that's the output, and this is the walk forward, so we can actually just connect that there, and we choose walk, right? So now everything's working and we can start to bring in those other animations. So say we want idle. I'm just going to do the unarmed ones for now since we don't have any weapons. So we can go and we can look for the idle unarmed. I have two choices if you download the asset from the course, I have two idle choices. You can choose between the two. This one is a little bit more, how to say, like he moves around a little bit more, the character. I like it. Okay, so we've got our idle, we've got our walk. We just need to bring in our run. I might zoom out a little bit. And so we choose animation and we can choose our run forward unarmed, right? Okay, choose that. Wrong node here. There we go. And if we choose run, now we've got that. Animation and sprint forward unarmed, right? And I'm just testing these as I go along to make sure that they're the right animation. Okay, that looks right. And finally, we've got our, I think it's called fall idle. Yeah, fall idle. This is we're going to be doing most of our blending since that is just how that looks. Okay, so we've got all of our animations lined up here. Now, the thing you might notice is that the transition between all of these is very instant. And there's actually a variable here called xfade time, crossfade time. So we can choose to crossfade. So what we can do is we can put like 0.2 in that. And so when you go to idle to walk, you can see that it moves pretty smoothly between the two. And then the other thing that I like to do is just put sync. I feel like it just helps a little bit better. It's not going to be perfect. We're not going to get like perfect movement, foot movement. When we decide to stop, it's still going to like not, if you were really looking, wouldn't look as good as if you put in more intentional state changes between all of these animations, but it looks good enough. Okay, so we have our very basic transition state machine. Now, you can name these nodes, and we will need to name some of them. You don't necessarily need to name these. You can if you want to. So you could just call this idle. You can call this walk, run, sprint, and in air. Maybe it's not really jumping. Okay, so we've got these animations named. Now you really only need to name them if you're intending to reference them via code. So I'm going to call this the unarmed movement. We'll call it that, unarmed movement. And that'll be our transition state for when we're not holding a weapon. You know, we don't have weapons right now, so we're just going to work on this part of the code. It's much simpler, so it's a lot easier to demonstrate, right, as we get started, right? So now we've got this nice little state machine here, and we've got all of our different transitions that we can go to. And this is where it gets exciting. I'm just going to save this. We'll go to the assets. We can save this under character model, right? Character model. Now, this is where it gets really exciting because we've done all this groundwork. We've spent hours creating a state machine that can easily move us between different states. And now we also have a state machine here. And what do you think gets really easy to do when you have a state machine in both locations? It's controlling this. This is going to be really easy to put together, right? So we do need to actually change the state, right? We're going to need a script and we'll add it to the character model, right? Character model. That's fine. Okay, so what I'm going to do here is actually give this a class name, not because I intend to use it in other places, but simply because it's going to be easier to reference when we're calling code from the player script. The functions become visible then. We don't really need a process. I'll leave ready there. We might need it later, but what we do need is a function, right? And we can just call it on state machine state changed, right? And it's going to take a state and it's a string, right? It doesn't need to return anything. Okay, we'll put pass. Now, see, if you can understand where I'm going with this, we can actually just emit a signal from our state machine that's controlling our movement to the script and just call on whatever state we want to transition to. Now, we do need to actually call on the animation tree. So I'm going to set up an export variable here, just called animation tree of animation tree. Okay. So how do we call to the animation tree? Well, you do it with a node path. That's, I think, the right terminology. So everything that we can do here is essentially a path. So if we actually click the animation tree, we've got parameters, unarmed movement, current state, transition request, right? So this, if you ever need to know what to look for, is something you can come to for the animation tree, the parameters. And this is the string that we need to pass in to actually do this. And if you hover over transition request, you can see it there. Parameters, unarmed movement, transition request. That's the property that we need to change. So actually, it's not a node path, it's a property path, right? So we just go animation tree and we put the square brackets in, and then it's a string, right? So you go parameters slash unarmed movement. You can just copy if you don't feel like typing it all. That way, you know you're not going to get it wrong. Slash transition request. And then you can just equal to state. So now you can sort of see how this is going to work. This state as a string needs to match these. But what are these really similar to? They're really similar to our states. Obviously not all of them, like aim, walk, and sprint, jump, and all that kind of stuff. They're a little bit different, but it becomes very easy to understand how this is going to all connect together. So we'll work on creating a signal for that and updating those animations in the next episode. I'll see you there. Okay, so let's get to work on starting to set up those animation state changes via code in our state machine. Obviously, we deleted the mesh, the character's not in here, but we've got this character node now, so we can drop this in. Let's reset the transforms on that, bring him in here. Now, I don't really feel like moving the character. I'd much rather have the character model 0, 0, 0, 0, right? We don't want to put any transforms on this model as long as we can avoid it. Don't forget, before we go any further, to set the animation tree in the character model to the animation tree in the scene, right? I use exports a lot. Apparently they're a little bit quicker, but they're also really easy to understand from a visual standpoint. And if the node path ever changes, it gets updated automatically. So they're really handy in that respect. I think I might have mentioned that earlier in the course. Okay, so what I'm going to do is just raise the collision shape. Okay, so I'm going to just go into the side view here, just zoom in a bit. We can reduce the size of this again because that was really big. Click on the collision shape and just raise it up so that it's the right height. You could also just look at its size. It's 2 meters tall, so we just raise it by 1 and it would be perfectly on the ground. The character looks pretty good. What you do want to do is just make sure that the collision shape is bigger than any of the movements that the character can do to prevent clipping into the world. So I think that's okay. I'm going to leave it. If I notice any clipping, I'll just make it bigger if I need to. In terms of height, I think it's fine to have a little bit on the top. You could probably reduce it, but it's going to mess with the ground, and I don't really feel like addressing that. So we'll just leave it as is for now, and if we notice any issues, we'll just take care of them later. Okay, so we've got a character, and we probably want to, do we want editable children? No, I think it's fine to leave it like that. But what we do want is an ability to emit a signal to that character model, which means we're going to need to set up some signals, and we're going to set them up in the motion script. So we've got our velocity updated signal, but we are going to create a signal and we'll have it match pretty closely this state machine state changed. So we go back to motion and we might just call it animation, just so we know. Animation state changed. Animation state changed, and it's going to have a state, which is a string. So that is what we need. And basically, we are going to want to connect that. We're going to do it here in this state machine here because it's just a little bit easier to do it here. So what we can do is create an export because we need a way to reference this character model, right? You could also do this with a singleton, but I think it's just easier for something small like this to create it here. The state machine needs a character model. we might just call this a character model, and it's going to be of type character model, right? And so we can set that now in the inspector. So if we click that, we can choose character model because it's the only thing there. And then we can create a ready function here. And in the ready function, we just need to connect all the states signals to the character model, right? So we can go for child, and then we can also type child as being a motion because all of these states inherit motion. We can say in get children, and then we can write child dot animation state changed dot connect, and we can go character model dot on state machine state changed. This should probably be called animation state changed to line up more correctly with the name of the signal. It's always good practice. It makes it a little bit easier to read. So I'm going to change that function name to on state machine animation state change. So it's very clear what's happening here. Okay, so now what that will do is every single one of the children of the state machine will get that particular signal connected to it, right? But what we're running into here is that the state machine is a class that it's inheriting, and it already has something happening in the ready function. Now, the way that it works in Godot is that this particular script, its ready function gets called first, and it's overriding that function. So we need to make sure that the rest of the function happens, right? So there's a special way of doing this. What we type is return super dot underscore ready, right? And that'll make sure that the rest of the ready function gets called, which is really important because if we want the state machine to create a state map and actually initialize, we need this ready function to be called. So really important that you remember to put that at the end. If you're having problems, make sure you come back and check that. Okay, now we need to actually emit the signal. So if we go to idle, in the enter function where we were printing out everything, we can actually just say animation state change dot emit, and we can just write in there what we want to write. And so what might help if you look at if you go character model, click on the animation tree, click on the animation tree here, just raise that up a bit. When we go back to the player, we can actually make that editable, and we can just click the animation tree so we can see it below. Then we can just go to each individual script. And so what you need to do is just make sure that these particular transition requests match what you write in the signal emission here. So we're going into idle, we want to emit idle. Okay, and I'm actually going to take a copy of this before I go further so I can just paste into the rest of them. Otherwise, it's a lot of typing. And so we just go for that. Now we go to run. We enter run. We want to change the animation to run. We come to aim. Aim is a little bit different because obviously when we're aiming, we're kind of doing the same thing as walking, or this one specifically aim idle. So we really just need to enter idle. But for aim walk, we should go to the walk state just for a little bit of extra flavor, right? Because we are moving a lot slower when we're in this state, right? We're moving at a slower speed, so it makes sense to be in the walking animation. Okay. Moving on, we go to sprint, right? Obviously, sprint. Pretty straightforward. Jump. This one, we're going to work on this later on, but for now, let's just put jump, right? And then same for fall. If you're already in the state, the animation transition here, if you put a transition request for an animation you're already in, nothing happens. So we actually do want that. There are instances where you will just walk off the edge and you want your character to do something. We only have the one animation for that, but obviously if you wanted to put in the work, you could go and find more precise animations for when you're falling. Perhaps when the character's looking down, the arms and legs will be doing something different to when you're jumping up. It's entirely up to you. You're in control here. So for fall, I'm just going to have it go to the jump. And for the sprint, I'm going to have it go to the jump as well. So all of these are the same. Jump, you could even have like a separate animation for these, but I don't. And same for sprint fall, we go to jump. Okay, so making sure that we've got the character model chosen in the state machine and that we're emitting a signal and that we have this receiving it and doing a transition request. And when we click the character model, we have an animation tree selected. Everything should go together, and fingers crossed it does. The camera is something that we need to fix. So just looking down here. So if I go to like the side view, obviously the camera is way too low. So we do need to change that because it's just sitting at a state that doesn't make any sense. We can raise that up probably to like 1.5. I think that looks okay. Let's have a look at the cinematic preview. Now, personally, you got to remember that the position here, 0.5 and 1.5, you got to go spring length of 1, right? For the edge spring length. So that's actually like way over here. And then the rear spring length is 1.5. So that is accurate how it's going to look. I do think we want to move into 0.5 on the X, just so we're a little bit closer, because obviously this character is a lot slimmer than that capsule. And this could be 1. I think that looks a lot better. Could potentially be a little bit taller, so we want it sort of around waist height. It's really up to you. Might change mine to 1.6. Okay, so just remember those numbers. For the edge spring length, we probably, like I said, we want to bring that to 0.5. And for the rear, what did I say? 1. So the rear 1. So just remember with the camera, we're not setting those programmatically. We are setting the rear and edge spring length for the aim. Those are going to need to change, right? I think let's say 0.3. 0.3, and I think 0.3 for both, right? Aim speed is fine. FOV is fine. Sprint FOV is 100. Sprint tween speed 0.5. Okay, so that looks a lot better. Now let's run the game and see how our code has worked out. Okay. How good is that? Okay, so we're running forward, and even when we run forward and we rotate, it looks good. Now, the one thing you might notice is the left and right, obviously, need to be addressed, because right now we're still running forward no matter what, but everything else looks right. So if you aim, we're walking. If we jump, we go to the jump. If we sprint, we are sprinting. So now we just need to get the rotation down, and we can do that in the next episode. So I'll see you guys there. We're cracking along nice. I feel really good about this. Alrighty guys, welcome back. Now we're getting pretty good. We've got our animations walking, we've got our forward, we've got our jump. When we aim, we walk, and when we sprint, we sprint. But there is an issue, and that is when we rotate the camera, the character follows. To be fair, it's not too bad, but I think what is normal is that the character does not follow the camera when you're not moving. And on top of that, obviously, definitely more noticeable, when we input left and right and back, the character is just running forward, which does not look good. So we are going to address them starting with the camera, because it's a little bit more straightforward, I guess you would say. So we have the camera. This controls everything. This is where we are rotating the camera. So we've got a camera look function. So this is where we have the information that we need to do the work that we need to do. So what we can do is simply emit a signal to the character model to let it know to update that rotation. So we can put a signal in, and we could just call it mouse rotated, and it's gonna emit a rotation. We can't use rotation, so I might just put an underscore in front of that, and it'll be a vector 2. All right, so we've got that rotation. We've got a warning here. Mouse rotated is declared but never explicitly used. That's okay, we're about to use it. Okie dokie. So we have, I scrolled too far down, the camera look. Well, pretty easily here, we can just, and we should probably do this to be honest, at the very end of the script, emit the signal mouse rotated dot emit, and the variable we want to send off is the camera rotation, because that is what is important to us. And we can use this for a couple of different things in our character model. Right now, we're going to start off with the rotation. So we've got that signal. We can simply just double click it. We don't have to do any fancy code here. We can click the character model, press connect, and we go to the character model here, and we've got on camera mouse rotated, right? And we've got that rotation. So what do we do? Now, the first thing I think we should do is store that variable so that we have it and we can use it for other things. So I'm going to grab the variable. I'm going to call it current mouse rotation, and it'll be a vector2. And well, we are going to set the current mouse rotation equal to the rotation. We're just going to update that whenever the mouse moves. Okay, now we need to rotate the character with that. So we can go transform dot basis because we need to reset the basis whenever we rotate something. And we'll use the function rotate object local. Again, we are rotating in the y-axis if you've forgotten. The y-axis is the one that goes through the character. We're in cinematic preview here. Turn that off. Is the one that goes through the character. So it's this up and down here. So that is why we need to rotate that, because when we rotate around that, the character moves like this. So we go vector 3 and it's 0, 1, 0 because that's the y variable. And simply we pass in current rotation dot x, because you got to remember that the mouse rotation is the left and right. So x is the left and right, and we want to rotate our y axis by that amount. Okay, that really should be all we need. One note on the rotation, this is current rotation. This is a positive number. If we go back to the camera, you'll notice that it's a negative number. So we are counter rotating the character model. So when we rotate the camera, say we rotate the camera to the, like this way, we are going to counter rotate the model the opposite direction. So it appears that it's staying in place. All right, so let's give that a run here and see how we go. And you'll see that, yeah, the character sits in place when we rotate the camera, which is pretty nice. But you'll notice that things fall apart pretty quickly when we move. So if I run straight ahead, that looks great. But what if I wanted to run over here? Well, now we've got another problem. The character isn't rotating. And that problem has now become a major issue because this just looks wrong, right? Not only the left and right are wrong, but also the forward and back are. So we can fix that, but we'll do it in the next episode. I'll see you there. Okay, guys, welcome back. Now, we were at this point now where we can rotate the camera, but whenever we input directions, our character just walks in the default forward direction and never changes, no matter which way we're pointing the camera. Now, this is relatively straightforward. We just need to rotate the character by whatever that vector is. So if you imagine you pressed W and D together, it would be a 45-degree angle. You want to rotate the character by this much. You also need to take into account the rotation of the character as well, and we can do that pretty easily. So the first thing that we need to do is get the direction of the input. Now that lives in the state machine, right? So we're going to do something very similar to what we did with the animation state, right? Whenever we change state, we update the animation state. Whenever we input direction, we can update the direction. Call this input direction changed. And it's going to emit an input direction. I can't use that variable because we're using it down there. So I'll underscore input direction, and it's going to be a vector 2. All right. So this is the variable here that we need to send off. It simply, if we come down to our code here, we've got set direction. We get the vector left, right, up, and down, and we manipulate. See, we got in a second variable here, which is actually a vector 3, and we manipulate that into like basis of the camera. Now we don't actually need that information. We can derive that from the current available information. And I find it's just a lot easier to separate the two when you're doing these kind of calculations. It makes the math a lot simpler. All right, so we have an input direction. Now we will emit that very similarly to how we do the animation state because, well, we have to do it on every single one of them. And it's kind of annoying to have to do that, right? So the first thing we need to do in order to get this connected is to create a function on the character model. So we can come back to the character model, and I guess I'll just put this at the bottom here. We create a function and we'll call it on input direction changed. And it's going to take an input direction. It's a vector 2, and it doesn't return anything. Okay, we can just put pass. So that's the name of the function we need to connect to. All right, so we can come back to the state machine. So we can do the same thing that we've done here, where we write child dot input direction changed dot connect, and we can write character model dot on input direction change. You can see it showing up there. I just removed those brackets, and that's it. We've connected the signal. So now we need to do two more things. We need to emit the signal, and we need to do something with it once it's been sent out and received from this function. Okay, so as we're building up here, when should we emit this function? Well, there's a couple of different options here, and we could do it in the set direction. This is when we ultimately get that information, but we don't really want to emit it in the idle state because we aren't putting in any input, and we don't want the character to simply turn around and face the camera, right? So we don't actually want to emit the signal in the idle state. So what I think we should do is just in each individual state, obviously not idle because that's the one we don't want to put it in, but say in the run, at the bottom of this, we emit the signal. So we can go input direction changed dot emit include, and we just add the variable input direction, right? So that is what I think we should do. So we've done that in the run. In the aim walk, we do want that same thing at the bottom of this state. We just put input direction changed emit. We got aim walk. We want sprint, same deal here. In fact, it'll be the same all the way down. Just try to remember to do it to all of them. And jump, and also fall. There's an argument for not including it in this one. It's not a big deal. Even for jump, maybe you want the character to just face the direction they jumped in. Would be acceptable. We can play around with that. And then same with sprint jump and sprint fall. All right. So we've got all of them there. Now they're all being emitted. Now we're not doing anything when we get to on the other end. So what do we do here? Well, we need to rotate the character, right? So there is a bit of an issue here where we're already doing a counter rotation on the character model. Let's open up this scene. So it's going to be kind of hard for us to do another rotation on that because we'd need to know exactly where and the difference between the rotations and all that kind of stuff. It's very difficult. Not impossible, but you know what's a lot easier is to just do a rotation on a subnode, especially since we have this hierarchy here. So armature is flipped by 180. If you remember at the very start, I noted that the character was facing the wrong way. So that's where my counter rotation is. Don't want to do it on that one. But the one above here doesn't have any rotations on it. And if I rotate this, it'll rotate the entire thing, as you can see here. So as a way of like sort of avoiding that mathematical conundrum, we can just rotate that. So we can create an export variable here. We'll just call it armature, and it'll just be a node 3D. It doesn't have any type. And so what we can do is click into this, choose the armature. And once we get that input direction, we can just rotate that. And what I might do is create a separate function for this that we can call. So we can create a function called rotate armature, and it's going to take an angle, which will be a vector 2, and it will also take an offset, which will be a float. Now this will be the current rotation of the character model, and it returns void. So let's just create some space down here. Okay, so how can we find out the angle to rotate? Let's create a variable called new angle, and it's a float, since we are just rotating the y variable. So whenever we do an input, we get two variables. We get an x and a y. And if you imagine them on a plane, we have like a forward, and then we also have, let's say you're pressing W and D together, you would get a 45-degree angle. If you imagine each one of those, one's pointing out at 0 and one's pointing out at 90. I'm doing a gesture with my hands, but I don't have the camera on, so you guys can't see it. I might draw a picture. And you need to figure out what angle would be. It's fairly easy to know at this point if you're pointing upwards and to the right that the middle would be 45 degrees straight up and on a diagonal. So that's what we need to figure out. And it is possible, I suppose, if you were using a joystick, that it wouldn't always be so simple. But we can figure out no matter what the level of input is, what that is using tan. Just press equals here. Atan2 is the name of the function. Now, if we click into this, you can get a description. Returns the arc tangent of the xy in radians, used to get the angle of the tangent to compute the value. The method takes into account the sign of both arguments in order to determine the quadrant. So we're going to get an angle back based on those two vectors. So we can just say angle x and y, angle y, Right. Okie dokie. And then simply we need to rotate this. So we can go armature dot basis equals basis. And then finally, for this rotation, we can just call armature dot rotate object local like we have for everything else in the past. We pass in the vector 3 and it's just the y-axis again, 0, 1, 0 there. And we pass in the new angle. Okay. And we're good to go. I'm leaving the offset off intentionally. We can put a little underscore in front of it. And when we call this function, we might want to make this default value of 0 so we don't actually have to calculate anything. And that simply means that we don't have to provide it. Essentially, you'll see here in a second. I don't know if I've mentioned that before. Rotate armature wants the angle, which is just the input direction. And it should be good to go. Okay, so let's run that. And everything looks pretty good. Obviously, at the end of everything, we're still facing towards the camera. So trying to put it at the end of the state didn't help with that, but that's okay. I've got a solution there. You might notice that everything looks pretty good. Now, things get a bit weird when we start rotating the camera. Obviously, this is why we need the offset. We can fix that. We just need to pass in the current mouse rotation .x. And then on this new angle, we can actually subtract the offset. Okay, so if you run this again, and when we rotate the camera, we are correctly facing the right direction. Now, we're still very snappy and we're always facing towards the camera at the end, which is a bit of an issue, but we can fix that fairly easily. The way to fix the snapping and the fact that we face towards the camera at the end is simply by doing some easing, right? So we can create a variable called direction or input direction. We can just call it input dir. We make it a vector 2. And essentially on this input direction change, we'll set the input direction equal to input direction.lerp, and we'll just pass in the input direction from the signal. And it wants a weight. 0.1 seems fine. What we can do is we can create an export variable here. We can call it the turn rate. It's just a float, and we'll make it equal to 0.1. And we'll pass that in instead of just hard coding that, right? Easy. Okay, so now we're going to pass in that instead of the variable from the signal, and things should start to look a little bit better. And as you can see, the way that we turn is a lot nicer, and that's all pretty good. And now we're sort of at that point where we can start working on other things like the weapons. We'll need to set up a lot more with the animation tree, and we'll also need to create a weapon management system. But we're cracking along now. We're going to start developing both the animation player and the weapons at the same time because they're sort of interconnected. If you think about the way that you pick up a weapon or swap a weapon, you need the character animations to do things, right? So we'll start by setting up the rest of the tree, most likely, and then creating the actual weapon system. But yeah, we've got a character that looks pretty good, rotates pretty nicely, moves around. If this is all you were looking for, you'd be set. Right, I'll see you guys next time. Okay, so things are looking pretty good. We've got our character moving very nicely here, but I've just noticed there's a few things that we can improve before we move on to the weapon. So one thing that I've noticed is that when we're running and jumping, when we go back to the run, we are having a very sharp animation transition, and that is fairly easy to fix. Plus, when we transition back, so I'll play this again, into the idle animation, we're actually doing that once we've landed, and we could try and transition a little bit earlier so that it looks a little bit nicer for us, and some other stuff we'll clean up as well. So the first one's pretty easy. In the fall script, we're just saying if is on floor to idle. So what we can do is we can do something similar to what we've done in the sprint fall. We've got a check to see if we're pressing sprint, then we go back to sprint. If we have direction, if it's not equal to vector 3.0, then we go to the run, and all else then we go back to idle. So we can implement pretty much the exact same set of conditions in the fall. So we can say if direction is not equal to vector 3.0, then we can go to finished.emit and we can go to run, okay? And then else idle. And that'll just help with the sharper animations on that when we're running going back to that. So now that'll look good because we're only implementing one transition. I believe if you go from multiple transitions at once, then it starts from the previous one. So that's why you end up with that harsh transition, because it cuts the transition of the fall animation directly from idle to then into run. So that helps a little bit. Now, to transition back early, we need to find out if we're close to the ground, right? Because right now we're just checking that if where is on floor, right? Which is, this function is just a call to return owner.isOnFloor, right? So we're just checking to see if the character body is on the floor. So if we're already on the floor, then we've already landed, right? So it's kind of, it's a little bit too late to be calling a transition. Now this is not so important for us since we don't have a transition animation, if that makes sense. So we don't have like a landing animation. If you had one of those, this would be even more critical. So we do need to implement it, especially if you plan to add one. So what we can do is actually raycast to the ground to basically just check a little bit in advance to see if we're going to hit the ground. So we can just add a raycast. Oh, that's come up on the wrong screen. So we can just add a raycast. We're going to use a raycast 3D here. We're not going to do anything fancy. In the inspector, it's got a target position. I believe that's directly down already, right? Yeah. And it's -1. You know what? It might actually be okay. It could potentially be 0.5. It could be a little bit smaller. Depends on the length of your animation, realistically. So we can just call this a floor raycast. This might come in useful for other things. We'll have it here. And what we can do is for the fall, export var floor raycast, and it's a raycast 3D, and that's it. We can just say assign that to the floor raycast. We'll need to do the sprint fall as well because it's the same exact thing. All right, so we've got that. What we need to do then is we can just simply say if floor raycast.is colliding, and here we will transition our animations. And we can do the same check as down here. So we can say if direction is not equal to vector 3.0, then we want to go animation change request. We're not actually going to change the state. We're just going to start changing the animation early. Animation change request dot emit, and we'll just pass in the animation that we want. So in this case, it would be the run animation. Else, we're going to go to idle. Animation change requested, and we'll dot emit to idle. Okay, and just remembering that even though these are the same, these could be different for you because this requires the animation. So we go back to the animation tree, and we can see we've got run idle here. And I suppose it's kind of difficult to tell exactly from here, but we're going to start transitioning early. We can exaggerate that just to get an idea of what that looks like. So we can make this like -2, which is higher than we can even jump. So we should just transition directly back into the standing. And you can see that we do that there. So yeah, it's a matter of, you could probably work this out with math and work out how high you need to be, like how long it takes, how long the animation transition is. For us, it's 0.2 seconds, I believe. So if you had a transition animation, you would want to know how long that animation is, but we don't have a transition animation. So really we only care about how long the transition is, which is 0.2 seconds, right? So in the jump, where's the stats? The time to land is 0.4. And so you can do a little bit of math. For us, it's really easy because half the jump height is half the amount of time, and it matches the time to land. So if we make this -0.05, we're going to detect it with 0.2 seconds left to hit the ground, which is the amount of time that we would like. So I don't exactly know if that's a perfect formula, but 0.5 for us is the right distance for it to be. Now, something that we do need to consider, and I don't know if we've looked at yet, is the layers. So right now our player is still just on layer 1. Now, we don't necessarily want our player to be on layer 1, we do want to mask it. Essentially, the way to think about these layers and masks is the layer is the collision layer that your object is on. So if something was to look at layer 2, it would find the player. But the player does only look for things on layer 1 at the moment. So it would not collide with things on layer 2. So it's going to collide with things on layer 1, and everything else it's going to ignore. Right? So if we brought something in here, we can bring a static object, static body 3D, give it a mesh instance 3D, and give it a collision shape 3D, and also give it a box shape. Give this a box shape, new box mesh. Okay, so we've got a static mesh, right? And right now it's on layer 1, right? Collision, layer 1. So the player is going to collide with it. So I bring it in here and I try to run into it. I have to jump over it, right? So if I remove it from layer 1 and instead put it on layer 2, I'm running straight through it. We go back to layer 1. We're running into it. So that gives you an idea, like a practical idea of what we need to detect. So I can just remove that static body. For our player, we want our player to be on layer 2. We don't want it to be on the world layer because we don't want to have something like the floor raycast detect the player, right? It's not right now because it's right below the collision shape, but depending on where you put that and depending on how your collision shape looks, it might be different from mine. You might end up with overlaps. And so the collision mask for the raycast should be on layer 1 because we want to detect the world, which is the thing that the player interacts with as the floor, but the way that the player interacts with the world, we don't want the floor raycast to detect it, basically, and vice versa. We don't want the player to be able to detect the raycast. So that we'll move this to layer 1. We'll put the player on layer 2, which I've already named. So I guess I talked about that at the very beginning, but never actually put the player on it. So now when we're starting to need to detect things outside of the world, it's becoming important. All right, so that is the floor raycast. That should help with transitions, especially if you have transitional animations. Next, we're going to do a little bit of refactoring. Okay, welcome back. So we have got our floor raycast and we've got our states and we're ready to almost transition into creating the weapons, but we've got a couple of things to clean up. All right, so the first thing that I'm noticing is that pretty much every single enter has an animation change request. We can come to the motion script, which is sort of like our base state for all of these different states here. It inherits state, but state is very skeleton. So we'll keep that sort of as skeleton as possible as we build up motion, just in case we want to use it for something that doesn't. Now we've got our signal animation change requested, but we don't have a variable for our animation. So we'll just create a variable here. It'll be an export variable and it'll just be called on enter animation and it'll be a string. Okay, so then we need to actually call this, and right now we're calling this on enter, which is where it makes sense to call, not in the ready. Obviously this has a ready statement, but it's mostly for setting up the movement stats, right? So what we need to do is essentially do an override here for the enter function. So we can come down here and go func enter, and it returns void, right? And then we'll just write pass here for now. That should be fine. We get that little blue arrow, which tells us that we're overriding the base class, which is what we want. And what we can say is we can just say if on entered animation. And so if nothing exists, we're just going to skip over this basically. You don't have to fill out the form, right? On enter animation. So that what we'll write here is animation change request. And we'll just omit the on enter animation. Okay, hit save on that. Now for all of these, we just need to replace their animation and their enter function, right? So for idle, it's idle, and we can just delete this, right? Because that's all it was doing. It wasn't doing anything else. So we can just not run that. We do have to be aware, so this one's just run, that if we are calling something else in this enter function, which I believe we will for run, as for jump, and aim entered emit, right? So this is a good example. For aim idle, we're just going to call idle, right? But we don't want to delete this enter function because we want to still call aim entered emit. So all we need to write is return super.enter. And so that'll make sure that the enter in the motion state still gets called right after this. Okay. Same with aim walk. We go to the walk animation. We can remove that, and then we can just write return super.enter. Same thing here. For sprint started.emit, return super.enter. Same for the jump here, return super.enter. For we have an easier time on enter animation, we could just remove this. It's no longer required. Sprint jump, same deal. On enter animation is jump, remove this, and then return super.enter. Sprint fall, much simpler, and we can just delete this entire thing. Okay, let's just run this and have a look how it looks. So just make sure that all your animations are being called correctly so that there isn't any problems. And if you do have any, maybe just go back and check and make sure that you are calling the right animations. Okay, so now we've sort of cleaned up our animation call a little bit. That's going to make things a little bit easier going forward. Okay, next we're going to handle the transition between equipping and unequipping weapons.